Welcome to the Vehicle Operations, Manufacturing Engineering Ergonomics Lab. This is a motion capture lab, and we actually are part of the manufacturing engineering team. What we do at manufacturing is we then are obligated to look at each of the components and make sure that it can be assembled. We determine the heights at which the vehicle is going to run down the assembly line. We do virtual builds. And in a virtual build, we'll come to a component and we'll say, I wonder if that can be assembled, and if it's going to put stress on an operator when they're assembling that. We could then bring that component into the motion capture lab and into this ergonomics lab. We then assess tasks that involve complex motions. We also do high profile studies here. So if we were asked to look at a strategy of where the antenna should be placed. So then we could bring in multiple vehicles virtually and determine the best location and strategy of where we would have the antenna located on all the Ford vehicles. Passive optical capture system. The cameras are all looking for reflective markers. Camera is actually looking for this cloud movement. We also have a head-mounted display and wireless data gloves should we actually want to get into some fine movement. So then the tricky stuff comes where the technology then says we need to take these cloud markers and match them to an animation. And so as Glenn moves, the digital human model moves. A study that is on the Ford Fiesta, and I want to know whether or not Glenn could reach an electrical connector, a hose, and a cap. So he would actually move forward and reach out to them. Jim's going to just give us a view and touch. And then we would be then capturing this posture. And then I'd calculate the stress on this shoulder and things like that. You're going to say, well, it's not very stressful, and you're right. But there will be a hose there, so put your hand on the hose. So in this hose, you're going to say, oh, that's not too bad of a posture. And I would say, absolutely. I'm working 2 to 3 years ahead of this being in the assembly line. So what I can do now is say, back calculate, if this hose is here, and Glenn's going to push it on like that, what is the maximum force that we can apply to that? So we can use the biomechanics within the model and say, in that posture, it can't exceed 17 pounds of insertion. And then that becomes the specification or the target that we then bring to the engineering team and say, okay, great location, no problem, we can reach it, but you can't exceed 17 pounds. So if you want to reach out with your, okay, you're going to do left hand, let's do the cap then. So there's a cap way out in front of you. So you're going to lean in like you're an assembly worker, and you're going for that blue cap. Use your right hand, and why don't you reach over then to the electrical connector. Way over to the right, there's a, oh, right there, yes, there's a little green connector. Yep. Good, and then maybe right in the middle there's that hose, that purple and green hose. Perfect. So what I do is I actually put a little prop there so you have an idea that you've reached it virtually, but the actual virtual data set is our engineering data set, the same that the engineers are releasing on a day-to-day basis, and we would get then the actual location, and this is then where we would use for hand collisions, make sure there's enough hand clearance and things like that, as well as doing the biomechanical analysis of insertion forces and things like that.